Hello, all you students who are stuck at home or wherever you are, just practicing your social distancing. Um, as I promised, I'm going to start shooting some videos of some cool ideas that you can build or build upon. That would be kind of fun and engaging. So normally, we would this time of the year we'd be working on our big independent project, but clearly that's not going to happen that way this year. And some of you are going to go ahead and barrel ahead with your independent projects, which I think is awesome. But I also want you to have opportunities to work on a series of fun projects that you can do at home with your robot that are maybe different. Okay? And the idea here is just to keep you engaged, keep you moving, keep you learning. All right? So all these projects are going to have certain aspects to them that require you to go maybe a bit above and beyond what's written in Chris Odom's text. All right, so you might have to do a little blending and research to make these work. So I thought I'd start with a game. All right, and this is a pretty fun game. It's actually rather addicting. I've been kind of hooked on it as I work on it, which is making me work a little bit more than I had planned on. The idea behind it is it basically just has three basic components. We've got a button. We've got, of course, the motherboard with the teensy on it. And I have a tricolor LED. Now notice mine is pointing up. I made that special so you guys can see it, so it'll be aiming toward my camera. But, you know, your LED is perfectly fine. This one's just oriented 90 degrees differently. And the basic premise of the game is there's going to be a random number generator, which you know how to use. And it's going to essentially roll the dice. And if it rolls a 1, 2, or 3, it's going to light this LED, either red, green, or blue. Your goal is to be able to push this button as soon as the light flashes red. Okay? And it's going to record the amount of time it took you to get to that button pushed. And it's going to go faster and faster and faster. You never know if it's going to be a red, green, or blue. So if you get a red or a blue and you push the button by accident, it's going to multiply that time by 5. All right? So it's going to give you a relatively large number. The goal is to get the smallest possible number. You want to get as close to 0 as you possibly can. If it flashes red and you don't get to the button on time, it's also going to give you a penalty. So it's going to add points to your score. All right? So the basic structure is pretty simple of the code. I think you can almost figure it out from what I just described. But I will tell you there's a couple of ways that come to mind right now about how I would measure the time. You could use pulse in, which is what I used, which is introduced in chapter 22 when you're using the ultrasonic sensor. Or you could use millis, which is introduced in chapter 10. Both of those things are going to be useful for keeping track of a time and being able to record it. So using one, I actually use pulse in, but you might want to use millis. It deals with milliseconds. The pulse in deals with microseconds, and it's a little bit more of a hassle having to deal with the variables big enough to hold it and making the numbers, in a usable scale. But whatever one is perfectly fine. And of course, it's going to have, like I said, the delay between light flashes, and it's going to get shorter and shorter and shorter. So that's going to be running in a while loop. All right. And there's a couple of if statements in there. So because you're going to see it gives you some snarky remarks if I do things wrong. All those things are going to be built into this code. So let me go ahead and load it up fresh. And I put some extra fun features in it, because I could. It's certainly not necessary. For example, you'll see when it loads, it doesn't just spit it all out. It actually is going to put it out in bits, and we get these cool little effects going on with the instructions. And it's waiting for you to touch the button to begin. So I'm going to go ahead and get it started. We'll run it through one time. I will say I watched this on video one other time, and because of the frame rates and the speed of this thing's going to be flashing, there's a reasonable chance you're going to see me from time to time moving or talking, and you're not going to see anything in the screen. It's because as this thing was catching an image, this thing was flashing or not flashing at that moment, and the frame rates didn't line up. Okay, let's get going. It starts off slow. Oh, there's a red. and it'll go faster and faster. And of course, you're coding the game. You can make it any rate you want. Some of you, oh, it's trying to trick me. Ah. Oh my God. Ah. All right, let's see how I did. Okay. So 2782. I've done better. Okay. I have not yet. I got down below 1,000 when I've played it for myself. But I've also done much worse. I accidentally pushed the button once or twice. And if you scroll up, we can get some data. You don't have to print this if you do it. You can see here it was 2 red flashes that I simply didn't hit the button fast enough. I was too slow. And again there I was too slow. Basically I did okay. Alright, my speed was, yeah, medium wise. And like I said, it gave me a final score. And then if I push the button, it begins again. And it reloads it from the beginning. So there's a seeder idea, of things you can build. And I'm going to shoot another video here in a minute. And, it doesn't have to be this game. You can build your own. So I'd love to see some students try to build games. Maybe we can get a couple good ones and share it with the class. And we can actually compete against each other at some point during the rest of the term. So I hope you found that interesting, and I will see you all again soon.